So every time a comet goes close to the sun and undergoes sublimation, the tail which is part of the it's a part of the comet is being lost every single time, every single orbit of the comet. So comets are pretty much doomed right from the beginning. And as I said before, here let's go back to this. Sometimes comets will come in from very distant. Um, you see this, notice this. The coma begins around three astronomical when it gets about 3 astronomical units from the sun, and then you start getting a tail, um, you know, anywhere between 2 and 1 astronomical unit from the sun. At any rate, the comets usually come from really far away. We'll talk about that in just a second, but so they're losing part of themselves as they pass by, and then they'll orbit again and lose more of themselves. And so that debris that's left by the comet, um, sometimes the Earth will pass through that debris, and that's actually the link back to meteorites, right? Or meteors, sorry, meteors. So when the Earth passes through that debris field, that's what we call a meteor shower. That happens the same time, at the same time every year. There's like 12, well, 10 or 12 of these so-called meteor showers, and that's just when the Earth passes through these debris fields. Uh, Generally, the debris field is floating through space, and like the last time the Perseid meteor shower, which is the famous meteor shower in the summer, when we pass through it, that is when the comet was, passing by like 300 or 400 years ago. So that's that debris field. It's not like a brand new debris field. But every time the comet orbits the sun, it leaves these new debris fields. All right, and those are the meteor showers. All right, so now we've sent other missions to comets. The Stardust mission, the Deep Impact mission. We actually crashed into a comet to see what it was made of. Yeah, I mean, you can see they're different. They're not necessarily spherical. This one's kind of an asteroid shape. So let me say one quick thing about comets. So here, let's go back to this orbit. Now, if as you can imagine, like this gas coming off the comet, and of course that's most extreme as it gets closest to the sun, the point where we call perihelion, the closest point it gets to the sun. Um, at any rate, when the gases are coming off of the comet, it can slightly alter the trajectory of the comet, right? Because here, let's go back to this. I mean, you can see there's gases coming off of these things as they get closer and closer to the sun, and that can actually affect, not greatly, but can affect the orbit. And it's the job of astronomers to predict where these things are going to be. I mean, that's a really important thing. All right, so there's another example of a comet. Well, this is the Rosetta spacecraft. It put a probe. If I remember correctly, we lost communication with the probe for a long time. All right, so back in the 1950s, I think it was, there was this guy named Kuiper, and this is his last name. And Kuiper made this proposal. He said, "Well, look, there is this flat region that's where all the planets exist in the solar system, and sometimes you have these shorter period comets. So shorter period comets are considered about of having a period around the sun of 200 years or less. Halley's Comet would be considered a short period comet. So Halley's Comet spends most of its time way out in the Kuiper belt, but then comes in towards the sun once every 76 to 75 years. Now, but the other thing is, then this is what Kuiper noticed, is that there are comets that come in at all sorts of angles to the plane of the solar system. And so, and those comets tend to have much longer periods in the thousands and thousands of years. Like some of them tens of thousands of years. Um, Now, we don't have historical records of those comets, but if when one passes by the sun, we measure it, and we can measure the eccentricity, and we can, of course, figure out the period because it's orbiting the sun. It obeys Kepler's third law, so you can figure out what the period is. So these things can go way out, and so this guy Kuiper proposed this region, which is now called the Kuiper Belt. And so the Kuiper Belt is a theoretical region around the solar system where all the icy bodies, these trillions of icy bodies, still exist from the original formation of the solar system. Now, the reason I call it a theoretical region of the solar system is because we've never actually gone there, right? Even the Voyager spacecraft haven't reached the Kuiper, the Oort cloud yet. These things almost certainly exist. I mean, the reason for that is we see all these comets coming in at really bizarre, great angles, and so surely there is this spherical region of icy bodies, and sometimes like what would cause these icy bodies that have been around presumably for 4.5 billion years, why would they just suddenly head in towards the center of the solar system? If let's say they're orbiting in going around the sun way out here in orbits of 100,000 astronomical units from the sun, why would they just suddenly head in towards the center? And so we think that has to do with so you're talking about almost a light year in distance from the sun, and so now you have to think about other objects in the galaxy. Now, the closest stuff that we know of to our sun is about 4 light years away. So even let's say a passing by star, they're not going to get as close as 100,000 light years, but even one that's like, I mean, stars are so massive. One that's about, I don't know, 3 or 4 light years away, if it passed by our solar system, it would influence some of these chunks of ice, and that would cause some of them to fall in towards the solar system. At least that's what the theory is. I mean, and it's a good theory. It certainly, explains all the observations that we've ever had. It's very cold out there. It's about the temperature of space in between the stars. The temperature of space is roughly 3 Kelvin. So that's, remember, there's absolute zero Kelvin, and then the space itself is roughly 3 Kelvin. So this is the idea of, you have a star that passes relatively close by, and that will cause these things to alter their trajectory around the sun. Oops. Let's see, where was I? All right. So again, short period comets, which are considered 200 years or less, come from the Kuiper Belt. The longer period comets come from this thing called the Oort cloud, which is a theoretical region of space, which is almost certainly there I mean, what else? Why would there be comets coming from all these crazy angles if there's not this spherical region, which we happen to call the Oort cloud? All right, so that's um, so remember the Kuiper belt is so the Kuiper belt is this. It's still a relatively flat region. The Oort cloud is much larger, right? It's much larger. We think it goes out at least 100,000 light years. Sorry, 100,000 astronomical units. Remember, one astronomical unit is the distance between the Earth and the Sun. Um, all right, so short period comets come from the Kuiper belt. Long period comets come from the Oort cloud. All right, so now let's get back to meteors and meteorites. So a shooting star, as they call them, is has nothing to do with stars at all. It is this little bits of debris, often, in fact, the material that comes off of comets, right? All that that gas that is coming off comets. And there's even like little grains of sand. It was as small as sand, um, like a single grain of sand. When these things hit the atmosphere of the Earth, that causes friction, right? Just rub your hands together, right? And you can the longer you rub your hands together, the warmer it feels, and it's the same idea. When a comet hits the Earth's atmosphere, there is this increase in temperature, and it increases so greatly that there's often a streak of light that is visible from the surface of the Earth. All right, and sometimes when the Earth passes, as I've mentioned this already, but I want to talk about it again. Sometimes when the Earth passes through one of these debris fields, and this is probably the most famous of them all because this is called a meteor shower. By the way, any given night of the year, you don't have to wait for a meteor shower for this to happen, but something that's in the solar system can hit the Earth and get this streak of light across the sky. They're usually really short lived, because they're burning up. So when the Earth passes through these debris fields, the debris fields seem to be from a particular direction, and we usually name the direction of whatever constellation that the meteors are coming from. So the Perseid meteor shower is really a very famous one. It happens in August, which in the northern hemisphere, of course, is summertime. So it's a very fun one to go and look at. And so all the comets all the meteors that you see that night seem to come from the same location in the sky. All right, so that's, in other words, there's the one for the Perseus meteor shower. There's different ones around the year as the year goes by, but that's probably one of the most famous ones. All right, so let's see. I don't know how much of this I can talk about. Now, remember when one of these meteors can actually survive the trip through the atmosphere and actually hit the ground, that's called a meteorite, right? A meteorite. Remember, they're meteoroids when they're in space before they hit the atmosphere. They're a meteor when it hits the atmosphere, and then if it can reach the Earth, it's a meteoroid. I'm sorry, it's a meteorite if it hits the Earth. All right, so now. We think that there was an object that roughly 66 million years ago hit the Earth and wiped out most of the life on the planet. Which the dominant species, of course, was the dinosaurs. Within just a few decades, the dinosaurs were gone completely erased from the historical